When you add and subtract rational expressions, you can pretty much use the same steps that you use to add and subtract fractions. So let's review a little bit about how to add and subtract fractions. Well, here I have 5/12 minus 7/18. And my first step is going to be to find a common denominator. So there's a lot of common denominators you could use. For example, you could just multiply 12 times 18. But the easiest way to do it is to find the least common multiple of the denominators. And the way you do that is by listing out the multiples of each denominator. So I have 12, 24, 36, 48. And for 18, you know what, I'm just going to list a couple or maybe a few here because I already have a common denominator or a common multiple, 36. So 36 is the least common multiple of 12 and 18, and that's what I'm going to use for my denominator. That'll be much less work in the long run. So now let's rewrite this expression using that denominator. Well, 12 times 3 is 36, which means I'll multiply both the numerator and the denominator of the first fraction by 3. And 18 times 2 is 36, which means I'm going to multiply both the numerator and the denominator of my second fraction by 2. And really, y'all, this is the same thing as multiplying both sides by 1, because 3 over 3 is just 1, and 2 over 2 is just 1. So now when I simplify this, this is going to be 15/36 minus 14/36. And all we did was multiply straight across for both of those fractions. All right, and of course, 15 minus 14 is 1, and our denominator does not change. So our answer is 1/36. So let's review those steps. First, we found a common denominator. Then we rewrote our expression using that denominator, and then we subtracted and simplified. So these steps are going to work for rational expressions. Rational expressions just take a little bit more work. We do, however, need to add one step at the beginning. When we have a rational expression, we need to find our excluded values. So the values that are not allowed in the domain. And those occur whenever the denominator is equal to 0. So in our first term here, our denominator is x squared. So x squared cannot equal 0. And in the second term, our denominator is x squared plus x. So we need that to also not equal 0. The values where those are equal to 0 will be excluded. So let's figure out what those are. Well, first of all, this would just be 0. And our second one, I'm going to pull out a common factor of x and rewrite this. So now that that's factored, I can see that the roots of this equation are going to be x equals 0 and x equals -1. So altogether here, I have two excluded values. I have x equals 0 and x equals -1. I don't need to write 0 twice. I understand that since it's on both lists, I only need to write it once. So we've already factored the denominators of both of these terms that we're going to add together, and that's very helpful for finding a common denominator. So I've rewritten my expression with the denominators factored, and that makes it a little bit easier to see what my common denominator should be. On the left, my first term has x times x. I'm multiplying two x's together. On the right, I have x and x minus 1. So my least common multiple and the best denominator that I can use here would be x times x plus 1, because it has everything that each denominator brings to the table, so to speak. I've got the x squareds from the left, and I've got the x and the x plus 1 from the right. So this is going to be my least common denominator. And if I want, I could write it like this. These are the same thing. Okay, so now let's rewrite the expression using that denominator. So the term on the left was missing the x plus 1 in the denominator. So I'm going to multiply both the numerator and the denominator by that. And the term on the right was just missing an x because it had x times x plus 1 and it needed to have x squared times x plus 1. So I'll multiply both the numerator and the denominator there by x. Now let's simplify a little bit. So first of all, I'm going to write all of this under the same denominator. Remember, my new denominator is going to be x squared times x plus 1. And these are the same thing. Here I have two x's times an x plus 1, and here I have two x's times an x plus 1. So both of my denominators are the same now. They're common. They're both x squared times x plus 1. Now let's look at the numerator. I'm going to need to use the distributive property to multiply my two polynomials together here on the left. So let's do that. First I have x times x squared. Then I have x times 4x. Then x times 2. Next I have 1 times x squared, 1 times 4x, and 1 times 2. All right, now let's go over to our second term over here. Here I just have x squared times x. So that's x cubed. All right, so this is looking pretty good. Now I have something where I can just add all of my like terms together. So let me identify those. So I've highlighted what I'll be combining. This is going to give me 2x cubed plus 5x squared plus 6x plus 2 all over x squared times x plus 1. So now I have added my rational expressions together, and this is my final answer. Now let's not forget our excluded values. So remember that at the very beginning we said that x cannot equal 0 and it cannot equal -1. So we want to qualify this saying that this is the sum of those expressions as long as x doesn't equal 0 or -1. So adding and subtracting rational expressions really is just like adding and subtracting fractions. Let's go to the next page so that you can try some out. Ready to try it out? Pause the video and see if you can do this first example. All right, did you give it a shot? Are you ready to see how to do it? The first step was to rewrite it with the denominator factored. I also rewrote my first term as having a denominator of 1, since its denominator was not shown earlier. This means that x is excluded when 1 minus x equals 0 or 1 plus x equals 0. So in other words, x equals 1 and x equals -1 are excluded. So the least common multiple of 1 and the product of 1 minus x and 1 plus x is just going to be 1 minus x times 1 plus x. So just the denominator that we already have on the right side. So on the left, I'll need to multiply both the numerator and the denominator by 1 minus x times 1 plus x. And on the right, I don't need to do anything. So factoring was helpful to find my excluded values and to find my common denominator, but now I'm going to just simplify by multiplying back across again. And then I can simplify even further by distributing in my numerator. And this looks like a pretty done answer, but I could actually go a little bit further. I could at least rearrange my order so that my terms are going from x to the power of 4 to x to the power of 2 to my constant term. And there we go. And I know that my answer is simplified because my numerator and my denominator have no common factors other than 1. So when is this expression valid? That would be when x does not equal 1 or -1. Remember, that was important. So let's not forget those excluded values we started with. And that's our final answer. All right, ready to try the next one? Pay attention, this one is subtraction. So you've probably got it down now. You know that the first thing we're going to do is always factor out those denominators. And that pretty easily gives us our excluded values. And once again, here we're going to have 2 of them, +2 and -2. Let's talk about our common denominator. This time, our common denominator is going to be just 2 minus x times 2 plus x. Because I have a 2 minus x on the right, and on the left I have a 2 minus x and a 2 plus x. So that's the least common multiple of those two. I don't need to change anything about my term on the left. It's good to go. And for my term on the right, I need to multiply both the numerator and the denominator by 2 plus x. So I'm going to simplify by distributing this 1 across. And what I want you to be mindful of is that really here, since this is a subtraction problem, I'm really essentially distributing a -1. All of this second term is going to be subtracted from the first term. So now let me rewrite this one more time. Now I'm going to write x squared minus x minus 2 over 2 minus x, 2 plus x. And this looks pretty done. This looks good. However, I may be able to simplify it further if there's a common factor in the numerator and the denominator. So let me factor out my numerator to check. Let's see, that would be x minus 2 times x plus 1. So it looks like it's very similar to the bottom term, but maybe not exactly. Let me show you a trick. These two terms look very similar, don't they? And they should, because the opposite of x minus 2, or the product of -1 and x minus 2, is negative x plus 2, or we could even rewrite that further as 2 minus x. So if I put a negative in front of x minus 2, it's equal to 2 minus x. So if I wanted to use an equation to express this idea, I could say 2 minus x equals negative x minus 2. So you know what? Now that I know that, let me replace this 2 minus x down here with negative x minus 2. And there we go. Now we have our common factor. So that becomes just 1. And we're left with our expression negative x plus 1 over 2 plus x. And remember that x cannot equal 2 or negative 2. So here's a couple of real world examples for you. Let's look at this first one. It's talking about a band contest. It says the fee to enter a marching band contest is $200. Band A and Band B both plan to enter the contest. The band members of each band decide to split the cost of the entry fee equally. We also know that Band B has 30 fewer members than Band A, and that Band A has X members. Now our job is to write an expression that can be used to find the difference between the number of dollars each person in Band A must pay and the number of dollars each person in Band B must pay to enter this contest. All right, well Band A has to pay $200 and they have X members. So each member needs to pay 200 divided by X dollars. And Band B, they also need to pay $200, but they only have X minus 30 members. So each member is going to have to pay a little bit more. So what would the difference between these two be? Well, we would take the amount paid by each member of Band B. Remember, that's a little bit more. And we're going to subtract the amount paid by each member in Band A. They have to pay a little bit less because there's more of them paying towards that 200. And this expression represents our difference. So how about you pause the video and try this next real world example? So we don't know the distance that Miss Jimenez lives away from the school, but we know that the amount of time it takes her to get to school is d divided by 40. That's the distance divided by her rate of speed. And we know the amount of time it takes her to get home is d divided by 50. Now if we add d divided by 40 plus d divided by 50, that's the total amount of time that Miss Jimenez spends driving to and from school every day.